Guys, welcome back to another video, and today we're going to be talking about the conjugate in with square roots. So let's dive into an example. So we have 2 times, over 2. And we're being asked to simplify this. So first of all, is this simplified? No, because you have a square root denominator. So how do we simplify this? So like rationalizing, we're going to bring something to the right into the top like we did in the previous video. But instead, we're just going to change the sign of this right here. We're going to change the sign of this. So I'll show you. It's sort of similar to rationalizing, but a little different. So if we have this example again, 5 minus the square root of 2. All we do is we change it to 5 plus square root of 2 times 5 plus the square root of 2 and then we FOIL on the top and on the bottom. So let's do the top first. So let's distribute this 2 into here. So it just becomes, on the top becomes 10 plus the square root of 2. And on the bottom, we're going to FOIL. So we get 25 plus 5 root 2 minus 5 root 2 minus root 2 times root 2, which is going to be minus root 4. And root 4 is 2, so then it becomes minus 2. So these cancel out in the middle, so we get 25 minus 2, which is 23 on the bottom. So let's try again another example. So if I have 5, 3 plus 4 root 3, the conjugate, why they call it the conjugate is because we take this same thing right here and we change the sign so they're like brothers, okay? And that's how we get the square root, we get rid of the square root. So we're going to do the same thing here. We're going to write the expression, let's change that plus to a minus, apply it on the top and the bottom. So now let's do on the top first. So we're going to do 5 times that constant, which is 15. And we're going to do 5 times that minus 4, which is going to be minus 20, times the square root of 3. We can't simplify this because these aren't dissimilar, because they don't have a square root of 3. We learned it in identities. So then we're going to do on the bottom here. So it becomes 3 plus 4 root 3 times 3 minus 4 root 3. So this becomes 9 minus 12 root 3 plus 12 root 3 minus 16 root 9. Root 9 is equal to 3, so it becomes minus 16 times 3. Equal to negative 48. The middle terms always cancel because it added to 0, so we get 9 minus 48, which is equal to negative 39. So this would be our final answer over here for the second one. So do you get the pattern? It's mostly it's just foiling and distributing. It's exactly what we did in the last video, but it's just applied here. So let's do another example. So 4 minus root 5. So what's the conjugate of our bottom right here? It's going to be 4 plus root 5. Let's bring it up on the top as well. And let's distribute. So 3 times that 4 is going to be 12. Now you're probably wondering, why aren't we multiplying with the side of square root? It's because of an identity, which says that the only time we can multiply square roots is when they both have square roots. So it has to be square root of a times square root of b equals square root of ab. Now there is an identity that n times the square root of a is going to be equal is going to equal n square root of a. So if we have 3 times the square root of 4 is going to equal 3 root 4. Again, I also did the example, if we go back here, a little confusing example, it was not this one, right here. So it was 5, I'm writing this in notation of multiplication, minus 5 root 3. Now this is a little confusing, but if you know identities, then you're straight. So let's multiply the first term. So these are just constants, we know this. So it's going to be 15. And then we're going to multiply it also to here. So it's just going to be 5 times that minus 4. So it's going to be minus 20. And then it's going to be root 3. So here you already had the n. We're just timesing everywhere we see an integer. So that's, I just wanted to make sure that you were clear on that. So let's finish the problem. So 12, and it's going to equal to 3 root 5. And the bottom, let's FOIL this. So it's going to be first, which is 16. Outer is going to be 4 times root 5. This is going to be 4 root 5. And here is going to be minus 4 root 5. And then this is going to equal to minus root 5 times root 5, which is going to equal minus root 25, which is 5. So it's going to equal to minus 5. Because the root 25 is 5. And then you have that minus sign, so you have to distribute. So we get 16 plus 4 root 5 minus 4 root 5 minus 5. These middle terms cancel, so we just get 16 minus 5, which is 11. So our final answer would be here. So notice I did the bottom and the top separately. Okay. So the conjugate forces the difference of squares. And you'll know you're doing this right is because the radicals disappear because they're being squared. Remember the identity. When you square a radical with the index being the same as what you're squaring it with, or what you're raising it, like exponentiating it to whatever like power you're doing, it's going to, they're inverses. So make sure you understand that. So let's just do one more. So we have 2 over 2 plus root 7. So let's do the conjugate for this one. So we're going to do the same thing. We're going to write it exactly as is, but just change the sign of what's between them, which is what the conjugate is. And now we're going to FOIL. So the top looks a little confusing. So it's just going to be 2 times 1 times the square root of 2 because it's invisible. So we're going to get 2 root 2. Same for here. We're going to get minus 2 root 7. This is in its simplest form because remember the identity for square roots, we can't add or subtract them unless they have the same number in the radicand, which here they don't. So this is the simplest we can get it as. Unless we factor, of course, but I doubt it here. So let's just do the foiling on the bottom. So square root of 2 times the square root of 2, which is going to be the square root of 2 squared, which is going to cancel out. So we just get 2. And then we're going to get plus, or actually minus, so if we do, let's just work this out here. So square root of 2 times negative square root of 7 is going to equal to the square root of 2 times the identity, so it's going to equal to the square root of 14, and it's going to be a minus sign, and we can't simplify this down because these are prime numbers, 7 and 2, and it's going to be the same thing here, but it's going to be the square root of 14. And then we're going to have this final, so it's going to be the square root of 7 times negative square root of 7. So square root of 7 times square root of 7 is 49. So it's going to equal the square root of 49. We have the negative sign we brought across, so it's going to equal to minus 7. So then our terms would be 2 minus the square root of 14 plus the square root of 14 minus 7. These cancel, so we just get 2 minus 7, which is equal to negative 5. So our final answer is this right here. Try with a variable. 2 times the square root of x minus 3. And let's go ahead and do the conjugate. Plus 3. 2 times the square root of x plus 3. So now let's times. So all we're going to do is we're going to times the constant on the top, so it's going to equal 8 times the square root of x plus 24. That's for the top. And for the bottom, we're going to get 2 times the square root of x times 2 times the square root of x. So it's just going to be 4 times the square root of x squared. Okay, so this is going to cancel. So all we're going to get is we're going to get 4 times x, which is equal to 4x. So that's our first term. And then we're going to do 2 times the square root of x times 3, which is going to equal to plus 6 times the square root of x. Here it's going to be the opposite. It's going to be minus 6 root x. And it's going to, and then our final term, which is negative 3 times 3, is going to equal 9. So then we cancel out here. So all we get is 4x minus 9. And that's our final example. So hopefully this helped. And make sure you understand the identities clearly. So I recommend watching my videos on the identities and everything for the square roots. And have a great day.